Everybody used to say the same excuse when I'm having internet is problem. Wait,
Noted, sir.
turn on your camera. Okay. Now moving to the next part here is that this is the first part. For example, let me explain you that if it is, you need to select it 1, 2, 3, 4, 5, 6, 6 carbon. 1, 2, 3, 4, 5, here 5. So in the white one, you are having 5. In the yellow one, you are having 6. Okay. So you will select the yellow one here. Okay. Not the red one, because red one is leaving the functional group. Still it is having 1, 2, 3, 4, 5, 6 carbon. But you cannot select it. You will select the yellow one because it is having the maximum number of carbon 1, 2, 3, 4, 5, 6, and also the functional group. So you have to select the longest carbon chain, which is going to have the functional group as well as longest carbon. Got it? Shoaib, are you there in the class?
Yes, sir.
Turn on your camera.
My camera's USB cord, right? It broke, so I don't have a camera right now.
Done. Similarly, if you are having 1, 2, 3, 4, 5, 6, 7 carbon in this chain, and here you are having 1, 2, 3, 4, 5, 6. So you will again select the yellow one. Okay, yellow one. So longest carbon chain you have to select including the double bond and triple bond. Means the carbon which is having double bond and triple bond, and the carbon which is to which the functional group is attached. Okay, that should be in the chain. Okay, for example, if you are having like this carbon is OH, okay, and this is another chain. Okay, so don't select it like this way 1, 2, 3, 4. Okay, this carbon 1, 2, 3, 4, 5, 6. Okay, and it is also 1, 2, 3, 4, 5. Okay, so this is the longest carbon chain. According to you, this is going to have 6 carbon, but still it is leaving that carbon which is having the functional group attached. So that should 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So you have to select it like this way. Because if you select it like this way, you will add 6 carbon, the maximum number of carbon. 1, 2, 3, 4, 5, 6. Okay. But if you select it like this way, then it is going to have only 5 carbon. 1, 2, 3, 4, 5. So this will be incorrect. So you have to select the longest carbon chain, including the functional group. Got it? Got it? Next is the numbering should be done in such a way that the functional group should get the lowest possible number. Second rule is, yes.
When choosing the longest carbon chain, do we include the functional group or only the carbon atom which has the functional group?
No, we are not going to have only the carbon. If some functional, if there is any carbon which is already, if there is some functional group which is already having the carbon, for example, aldehyde. Okay, so that carbon of aldehyde should be in the chain. For example, this is the aldehyde, or here is the carboxylic acid. Okay, COH. COH. Okay, so this carbon should be in the chain. So this will be considered like this. Okay, the functional group, if it is having its own carbon, then that carbon should be in the chain. You cannot use like this. You cannot use that. You cannot say that it is at the second position. No. If the functional group is having its own carbon, then that carbon should be in the chain. Then that carbon should be in the chain. If you choose like this, then this carbon is not in the chain. So that should be in the chain. So you have to choose like this. Okay. And if it is, if we are having any functional group which is not having its own carbon, like for example, alcohol, so the functional group, the carbon with which this OH group is attached should be in the chain. That should be in the chain. Got it? Got it? If the functional group having its own carbon, then this carbon should be in the chain. If it is not, if it is a functional group which is not having its own carbon, then it should, then the function, then the carbon which with it is attached, it should be in the carbon chain. Got it? Next.
Yes, sir.
Second step. Numbering should be done. Numbering should be done in such a way that the functional group should get the lowest possible number. Let me write. For example, if you are having this OH group, okay, and in this case, let if you are having this OH group here, okay, And the third case, if you are having, okay, this OH group here. Okay, the main functional groups are COH, CHO, CO, ketone, okay, C double bond O or CO, ketone, R, and the last one is OH group. These are the main functional groups. So these main functional groups should get the lowest possible number. Means their carbon should get the lowest possible number. Okay, so if this is alcohol group and if it is attached, then we have to write it 1, 2, 3, 4, 5 like this way. If you write it like count it from here 1, 2, 3, 4, then this is at the fourth position. No, you will not write like this. You will write numbering like this. And if it is like here, you have to write numbering like this 1, 2, 3, 4, 5. Okay, got it?
Yes,
Numbering
sir.
should be done in such a way that the functional group should get the lowest possible. The carbon with which the functional group is attached should get the lowest possible. And if, for example, except the ketone, for example, aldehyde. Like for example, if I'm having this carboxylic acid, okay. So first of all, you cannot select the longest carbon chain like this way. Why? Because the functional group carbon is not in the chain. It should be in the chain. So you can either select it like this way, 1, 2, 3, 4, or like this way. But you have to select it like this way because you are getting more number of carbon in the chain. 1, 2, 3, 4, 5.
5.
Okay. And these two carbon will be considered as branch. We'll discuss this one. And the numbering should be done in such a way that the functional group carbon should get the lowest possible number. So this will be 1, 2, 3, 4, 5. Okay. But if we are having alcohol like this way, and we are having this OH group attached like this way, so don't give this carbon as first number. No. This will be given third. 1, 2, 3, either from here or there from, because this is not the functional group carbon. If there is functional group carbon, then this number should be given as the lowest. Okay, because we are just including this carbon in the chain, na? So this is our chain, but here this is our chain. Okay, got it? So this is our chain. So numbering should be done in such a way that the functional group should get the lowest possible. So from here or here, it is going to get 3. So it will be okay. Got it? But if you are having a double bond like this, for example, if it is double bond here, okay, then the numbering should be before. If there was no double bond, then you can either do like this 1, 2, 3, 4, 5. It is still 3, or you can do 1, 2, 3, 4, 5. It is still 3. But if you are having two functional group, then and the main functional group is going to get the same number 3. So you have to use it from here 1, 2, 3, 4. And if you do it like this, 1, 2, 3, 4, 5. So if you do it like this way, this double bond is at the first carbon. This double bond will be considered as first carbon. But if you do it like this way, this double bond is at the fourth. Because this main functional group is going to get the 3 position from here or here. So try to use this position so that this will also get the lowest possible. Are you getting? Are you getting?
Yes, sir.
Let me explain you one more time. For example, if this is a carbon and main functional group is going to get 3 either from this side or this side. And if I'm having double bond here, so I will do the numbering from here. This will be given preference. Why? Because if you do it like this way, then the double bond alcohol is
Gets the lowest number.
Alcohol is going to get the 3. Okay, but this carbon, if we do this from here, it will get the first number. This carbon double bond will get the first number, and if we do from here, it will get the 1, 2, 3, 4 numbers. So we will give the lowest possible number to the other functional group if it is possible. Okay, got it?
Yes, sir.
So the main functional group should get the lowest possible number. Okay, for example, if I'm having this is 1 chlorine and this is 1 OH group. Okay, so if I got it, I will got it 1, 2, 3, 4. If I do it like this 1, 2, 3, 4. So since this is the main functional group, alcohol is the main functional group. These are the 4 main functional groups: carboxylic acid, aldehyde, ketone, and alcohol. this function group, if possible, should get the lowest possible number. So I will try to give 2 to the alcohol and 3 to the chloride. And if I do it like this way, then 2 will be given to the chlorine and 3 will be given to the alcohol. So we'll say that we will do it like this way. So that 2 will be at the alcohol and 3 will be at the chlorine. Got it?
Yes,
Got
sir.
it?
Yes, sir.
Okay. More. Next is, if we are having double bond and triple bond like this. Another we are having chlorine atom. Okay. Okay. Or chlorine atom here. Let's suppose it is, if I do it like this, 1, 2, 3, 4. And if I do it like this, 1, 2, 3, 4, 4. So the preference will be given to the double bond. After the main function group, preference will be given to the double bond and triple bond. Then this chloro, bromo, iodo, and nitro. Okay, these are the least one. Their preference is none. Okay, so the more preference will be after the main functional group. Like we have COH, like we have CHO, then we have ketone, then we have alcohol, then we have double bond, triple bond. Okay, and then we have chloro, bromo, iodo, and nitro. Okay, so numbering should be given preference. So we will do it. We will not do 1, 2, 3, 4. If we do it like this, chlorine will get the first number and the third number will be given to the double bond. So we will do it like this way. So the first number will be given to this carbon double bond, and the fourth number should be given to this chloride. Got it? Got it?
Yes, sir.
Now moving to the next part, third rule. If we have more than one prefix, then their different prefix. More than one different prefix, then their name should be written in alphabetical order. So I told you, when we are going to have prefix, then we have root, then we have saturation indicator, then we have okay. This is very interesting one. Okay, so if I talking about this one, that prefix, so prefix I told you it can be or cannot be. If it is present, it can be one or more than one. So what would happen if we have more than one prefix? Tejasvi, where have you gone?
I'm here, sir.
But your camera is not here, it means you are not here.
No, sir, I'm here.
You should be here always. I'm very much proud of you. You're going to score very good marks. Just concentrate here. Okay. So that the face expression is very important for the teacher. So that I can understand whether you are looking at me, you are looking at the screen. Sometimes the students is looking like this way. So I told them, hey, look at the screen. Okay, where are you looking? I'm teaching you important thing. So this is very important. Okay. So if I'm talking about the prefix, if I'm talking about the prefix, talking about the prefix Wait a minute, dear students. I was out. Sorry for this one, but I don't know why my laptop got stuck. And what I was teaching you all goes away. Okay. So wait a minute. Let me ask. Wait a minute. Is I'm audible to you? Hello?
Yes, sir.
Okay, wait a minute. सर मैं मीटिंग से बाहर Okay. So I was teaching you the third rule. Sorry for the inconvenience. Okay. Third rule was that if there is more than one prefix is present, okay, if there is more than one prefix is present, then their name should be written in alphabetical order. Their name should be written in alphabetical order. Understood? For example, if I'm having this, okay, this car, and if it is having one methyl group, one chloro group, okay, and one bromo group, okay, Br. So this bromo, chloro, and this chain is always written in alphabetical order, or these are used as prefix. Prefix is written for, tell me, prefix is written for, tell me, prefix is written for halogen groups like chloro, like bromo, like iodo, okay, like carbon, one carbon chain, like two carbon chain, C2H5 is two carbon chain, like three carbon chain, okay. So if we are having their names, more than one prefix is there, okay, one nitro, okay, like if I'm having one nitro, so their name should be written in alphabetical order, okay. So we'll write it like this way. We will number it 1, 2, 3, 4, or we can write it 1, 2, 3, 4, 5, okay. So if we do it like this way, 1, 2, 3, 4, 5, so we can do 1, 2, 3, 4, 5, okay. Then we will say that at 2 position is nitro, N, okay, and that 3 position is chloro, okay, and that in 4 position is methyl. One carbon chain is considered to be as methyl group, okay. So at 4th position is methyl, and then at 5th position is bromine. At 5th position is bromine. Okay, so we will write B first. So we'll write 5 bromo. Okay, then comma 5 bromo. Don't write comma. Okay, we will write when we are having an English word and a mathematical word number, then we have dash on it between it. Okay, then another position is after B we have C. So we will write 3 chloro, like this way. We'll learn when we practice this one, we'll learn this one, okay. 3 chloro, and then after we have 4 nitro, okay, and sorry, 4 methyl, 4 methyl, because 4 methyl, and then we'll write 2 nitro, okay. You got it? So their name should be written in alphabetical order, okay. Got it?
Yes, sir.
Yes, sir.
Yes, sir. So please turn on your camera. Okay, let it be. I think my laptop got stuck about due to that one. So today I'm not going to take the risk. In the next class, I will take the risk. Okay, when I will teach you at home. So today I'm taking this from my institute. So that's why, because I have there 2 setups. So I can start another one if my laptop got stuck. But here I don't have an extra setup. Okay, so okay, Tejasvi, very good. Okay, now moving to the next one is, so what was the rule? Third rule was, if there is more than one prefix is present, then their name should be written in alphabetical order. Have you written the second rule? Tell me, have you written the second rule?
No, sir.
Not written? So write the numbering should be done in such a way that the functional group should get the lowest possible number followed by double and triple bond. And priority, write it whole as a whole. Okay, write it as a whole. Write it as a whole. Okay. Numbering should be done in such a way that the functional group should get the lowest possible number.
Noted, sir.
Done, everyone in the class? Noted?
Yes, sir.
Very good. Now, for example, if we have chloro, okay, and here is their name, preference should be given to the carbon of aldehyde, okay? Got it?
Yes,
Got
sir.
it? Now, if there is more than one different prefix is present, more than one different prefix is present, then their name should be written in alphabetical order. So note it down. For example, if we have ethyl, C2H5 is ethyl, and this one CH3 is methyl, and this one is chloro. So first we will write chloro. Note it first. First note it down, then note it up to here, then I will explain you. Done?
Done, sir.
Other? Tejasvi, Jobita, Shweb, Saima. Saima, why were you late? Saima, are you there?
Yes, sir.
Why were you late? Hmm? You were late for about
I
15
was
minutes.
sleeping.
And that is not fine. It's not fine. We always need to. Okay. So let's start. So their name should be written in alphabetical order. Okay. Got it? Like we have this one, this one, this one, this one. So we will give, first of all, numbering should be done from this because this is the main carbon functional group. So numbering should be, this carbon should be given the lowest possible number. So 1, 2, 3, 4, 5, 6. We have done the numbering. Now at 2 position we have bromo. At 3 position we have 1 carbon chain, that is methyl. At 4 position we have ethyl group. 2 carbon chain is ethyl group. Okay, and then we have chloro, and then we have this. Okay, so We have second number bromo, B comes first, so we'll write 2 bromo. And after B, we will not write 3 methyl, no, because M does not come first. C come first, so we'll write 5 chloro. After B, we write 5 chloro. Don't write their name one, that 2, after 2 will 3 position will come, no. Numbering is not given the preference. This letter is given the preference, okay. So bromo, then we have 5 chloro, then we have 4 ethyl, E come first, and then we have 3 methyl, okay. This will be written as prefix. Got it? Got it?
Yes, sir.
Yes, sir.
The next and last is if we have more than let's suppose if there is more than one same prefix is present, like we have methyl group here and one methyl group here and one methyl group here. So we'll number it like this way. If from where the numbering should be done, from this side or from this side, tell me. From the right side, sorry, left side, or from the right side or from the left side? Is actually the right side. And this is the left side. Okay. So from which side should you do the numbering? From right to left or left to right? In this case. In this case, will you do the
Sir, right to left.
Right to left? Why? All are CS3. So if you do 1, 2, 3, then the first functional group is 3 position. And if you do it from here, so you will get first functional group at second position.
Second position.
So you have to do it like this way, okay? From left to right. Got it? And if we have more than one prefix, we will not write it like this way. 1, 2, 3, 4. Okay, we will not write 2 methyl, then 3 methyl, then 4 methyl. We will not write it like this. We will write first year position if it is same 2, 3, 4. First we will write the position at 2, at 3, at comma and 4. We have trimethyl. Tri means for 3 methyl. Means there are 3 methyl. If we have only 2, like this one, CS3 here, CS3 group here, and CS3 group here. Okay, then we will write 1, 2, 3, and 4. If you do it like this way, you will get still 2, 3. Here it is also 2, 3. So numbering either you do from here or do from here, same. Okay. So here you will write 2, 3 dimethyl. Okay, dimethyl. If there is more than same functional group is present, then we will use di, tri, tetra before their name. For example, 1 chloro here, 1 chloro here. So you will write 2, 3 dichloro. Dichloro. Okay. Got it? Got
Yes,
it?
sir.
So what you will write here? If more than one same prefix is present, then we use di. If it is present 2 times, if it is present 3 times, then tri. If it is present 4 times, tetra. So we use di, tri, tetra before their names, and we don't consider di, D of di, and T of tri, and tetra, 3 of tetra in alphabetical order. Only, okay, for example, what I'm saying here in the statement, let me explain you. For example, if we have written like this way, okay, so if you have methyl group here and one methyl group here, okay, it is methyl at 6 and 5 position, because we are just doing, this is the main functional group, so numbering should be done like this way, okay. And we have ethyl, this is ethyl at 4th position, okay. So E will be considered and M will be considered as, you don't consider it, we will write dimethyl. Now it will become D, and D will be considered as alphabetical order. No, only the letter of the functional group is considered to be as. Di is the rule. Only the name of the prefix is considered. We will consider it in alphabetical order. Okay, what I'm saying here is, for example, this is methyl, and we have dimethyl at 5,6. Okay, so 5,5 at 5, and at 6 we have CS3 group. So at 5 and 6 dimethyl and 4 ethyl. If we write it like this, it will be incorrect. Why? Don't give D as the preference. We write 4 ethyl because E come first and M come at later. D will not be considered as a preference for writing the IUPAC name. Understood? Di, tri, tetra. Okay, the D of di and T of tri and T of tetra will not be considered as a letter for comparing in alphabetical order. Okay, only the functional group name. Okay, got it?
Yes, sir.
This will be considered as a correct one. This will be considered. We will not write it 5,6 dimethyl. Why? Because if it is having di, D will come first. No, D will not be considered. M will considered first. So M will come later. So we will write 4-ethyl. This 4-ethyl because at 4th position we have ethyl group. C2H5 is ethyl. So 4-ethyl and 5,6 dimethyl. Okay. So write this one. If more than one same prefix is present, then we use di, tri, tetra before their names. Note it and write the example also. Write this one also and this one also. You will write it cross. This will not be and this will be okay. Write it. Done? Noted everyone? Shoaib, are you writing?
Yes, sir.
Abhi, Jobita, Saima, are you getting the rules of IUPAC?
Yes, sir.
Okay. When we will practice, you will learn the rule. Okay. For example, Abhi, we can say that you are not, if you are not familiar, then it's okay. It is a natural thing. Okay. Because you are doing this for the first time. You have never studied this anywhere before. So you are studying this one in the first time. So don't worry. When you practice this one, you will get each and everything. Okay.
Yes, sir. Noted, sir.
Other students, Jobita, done. Saima, Tejasvi, Shoaib.
Done,
Okay.
sir.
So Jobita, when you're done, please let me know. Okay.
Done, sir.
Okay. Now next is talking about the next one is if I'm having C, that for example, if I'm having this one, okay. Now we now know how to write the prefix, okay. Prefix rules. If there's more than one prefix, then their name should be written in alphabetical order. If they are more than same prefix, then we use di, tri, tetra before their names. Okay, we know what are the which functional group is used in prefix like iodo, chloro, bromo, nitro, and a carbon chain. Okay, carbon chain like CH3, like CH2, C2H5, like C3H7. Okay, these are the prefix that we are going to use. Okay, next one is after the prefix. we will have root. Root is the number of carbon chain required. Okay. For example, if you have selected a carbon chain and you have 5 carbon in it, then the root for 5 carbon will be pent. For 6 carbon, we will hex. Okay. So they are the root that we use for writing the names. Okay. For 1 carbon, we have meth. For 1 carbon, we have meth. Okay. And this is if we have 1 carbon chain only, no other means. So this will be considered as meth. Okay, meth will be used for this. So this is number of carbon. If it is 1 carbon, then meth. If it is 2 carbon, then eth. And if it is 3 carbon, then prop. Okay. And if it is 1 carbon chain, if it is only, let me tell you that if you have selected 4 carbon, so for 4 carbon, we will use prefix as, sorry, root as bute.
Bute.
Okay, if we have 3 carbon chain, so if we okay,
Prop.
then main chain that will be prop. But if we have 3 carbon branch, like we have 3 carbon branch, this is the 3 carbon branch. Okay, then this will be considered as propyl. Propyl. If we have 2 carbon branch, okay, if we have 2 carbon branch, then it will be considered as ethyl. Ethyl means eth. If it is only main chain, then eth. And then if we have branch, then YL will be added, ethyl. Okay, so please note it down here. Note it down here. Number of carbon, 1 for meth, eth for 2. Note it down. Root.
Sir, we have already written this down.
This we have already written. Okay. And then if we have alkyl group, 1 carbon chain, methyl, 2 carbon chain, ethyl. Okay, and 3 carbon chain, propyl. Okay. Next is the saturation indicator. Next is saturation indicator. If we have double bonds, do we have written this one also? If we have double bond between carbon-carbon atoms, then we will use E and E. If we have triple bond between any two carbon atoms, for example here, then we will use YNE. And if we have single bond, then we will use ANE. Okay, got it? The saturation indicator is, it can be ANE, ENE, and YNE. Okay, got it? And suffix, if we have alcohol group, then we will use all. If we have carboxylic group, then we will use oic acid. Okay, so for example, if I'm going to write the name of this one, okay, so I'm not writing the hydrogen here. You can consider that this is CH2, sorry, CH3 like this way. Okay, then it will be CH2 here. This carbon has used 3, so it will be only CH. It will be CH2. Okay, so how many carbons are there in the chain? First, select the longest carbon chain. So you will select this longest carbon chain, including the functional group carbon also. Got it?
Yes, sir.
Then the numbering should be done in such a way that the functional group should get the lowest possible number. Okay. So this 1, 2, 3, 4, 5. Okay. Got it? 1, 2, 3, 4, 5. Got it?
Sir, we won't include the hydrogen.
No. Hydrogen is not included. Only the carbon. Okay. Got it?
Yes, sir.
Next. Numbering is done. Now we have prefix. We need to write the name prefix first. So is there any functional group whose name is written as prefix? Is there any functional group whose name is written as prefix? Yes, the branch, if chain is attached, CH3 chain is attached, and their name is written as prefix. Okay. So first we will write prefix. So at 3 position, 1 carbon chain is present. 1 carbon chain is present. At 3 position, 1 carbon chain is present. Okay. So you can write it like this way if you are not getting that. This is like 1, 2, 3, 4, 5. Okay. And this is 1 carbon chain. We have chosen this one as the main chain. So this carbon is considered to be as branch. So prefix for 1 carbon is methyl.
Methyl.
And at which position it is? It is at 3 position. So you have to write 3, and then mass and English alphabet should have a dash. Okay, a number and English alphabet should have a dash. Okay, then is there any other prefix? No, there is no other prefix. Okay, got it? Prefix is done. The next one is root. Root. Okay, tell me the root of 5 carbon, because we have chosen the 5 carbon. So you will write root for
Pent.
5 carbon. Pent. Don't write it capital letters. Only the first letter should be capital. Other letter should be small. Pent. Okay. Is there any double bond between carbon-carbon atoms? Between carbon-carbon atoms. Don't think that COH is going to have double bond between carbon and oxygen. This will not be considered as double bond. We are just talking about if carbon-carbon is going to have double bond. Okay, like here, like here. No, there is no double bond. Okay. Got it? So if
Yes,
there is
sir.
no double bond, we will use ANE. As a saturation indicator will be used as ANE. Okay, pentane. Okay, and then oic acid. Oic acid is present at the first position. So we don't, if we are at the first position, like we have 5 on 1, so it is understandable that it is 5. If a number is written as 5, it means 5 on 1. So similarly, if we are not writing the position of the functional group, it means it is at the first carbon that you have chosen. Okay, got it? So we will write the suffix now. Suffix is the last one is suffix. So suffix is oic acid. Oic acid. Okay. So now this O and E is at the same, means these are the two vowels, and two vowels cannot be written simultaneously. Okay. Okay, we cannot write the two vowels simultaneously. So this E will be cancelled out, and we will write the name of this one as, 3-methyl pentanoic acid. Got it? Got it?
Yes, sir. Yes, sir.
Yes, sir.
What should be the name of this one? There is no functional group which is having suffix, sorry, prefix. This one is saturation indicator, and this one is suffix. Okay. So there is no functional group in this one. There is no chloro, bromo, iodo. No. There is no branch like this. Okay. This is the straight chain. So there is no prefix. Okay. So prefix is not here. Okay. Then we will move to root. Okay. I've told you that there can be a prefix or not a prefix. There can be a suffix or not a suffix. Okay. So what should be the name of this one? Tell me. Eth. Root for 2 carbon is eth. Okay. Then eth is done. Now we will have, is there is double bond in anywhere in the carbon between carbon atoms?
No.
No. So for if it is single bond, then we will write N.
A-N.
Okay. A and E, but E will be replaced because we are going to have the suffix, and which is all. For functional group, we have alcohol, it is all. So we will not write here E. Okay, E and E, we will remove it and we will add it all. So this is ethanol. Ethanol. Okay. Got
Yes,
it?
sir.
Ethanol. So we'll give you some, you have to practice, we'll give you some homework today in today's class, and you have to practice those one in the homework so that you can, okay. For example, if I'm having the next one.
Sir,
Yes.
so can I leave the class?
No.
Sir, I have another tuition.
So wait for 5 minutes. 2 minutes only. 2 more minutes. Okay. So what should be the name written to this one? Given to this one? Tell me fast. You will write 1, 2, 3, 4. The main functional group should get the lowest possible number. Okay. Then you have at 2 and 3 position, you have a prefix that can be written as prefix. Okay. So you write 2, 3 dichloro.
Dichloro.
Okay. Why dichloro? Because they are 2. And why you cannot write 2, 3? Because they are the same functional group. Okay. So when we have same functional group, we use di, tri, tetra before their names. So 2, 3 dichloro. Then 1, 2,
Bute.
3, 4.
Bute.
Okay, so for this one, we have the root, that is bute. Then carbon-carbon single bond.
Ane.
Okay, I'm writing here. I'm writing double bond here. Okay, that I'm positioning double bond here. Okay, yes, I writing this one. Then we have to write the position of the double bond. So it is at the first position. Okay, if it is at the first position, then we will not write the first position. Okay, if it is at the 2 position, let's suppose if it is here. Okay, 1, 2, 3, 4. Then we will write 2 bute ene. Okay, at 2 position we have ene group, and then E will be removed and we have all. So this will become 2 ene all. Okay, got it? So if it is not, if double bond is not here, then we will do it like this way. Got it? Got it?
Yes, sir.
So we have to, if there is double and triple bond, if the double bond or triple bond is at the first carbon, then we don't write it. We will write it bute ene all. If I instead of here, if it is here, then we will write bute ene all, because ene means double bond is at the first carbon. But if it's not at the first carbon, then we have to give the position that it is on the second position. Then 2 ene, 2 at 2 position it is ene, and then all. All is at the first position. Okay, got it? So we'll practice this one. Okay, and we'll give you some homework. Try to write the names of this one. That's all for today. You can leave. Okay.
Thank you, sir.
Thank you, sir.
Take care, everybody. Hello, Dilla. How are you?
I'm great.
Are you
sir.
fine?
How are you?
Good evening. I'm also fine. What about you? How your
I'm
studies is
fine.
going on?
I'm fine, sir. Thank you.
Okay. So what topic we were studying in the previous class?
Sir, just 1 minute.
Sir, we were doing metallurgy.
We are doing metallurgy, and I think we have not done the electrolytic refining.
Yes, sir.
We have not done the electrolytic.
No, sir. We did till electrolytic reduction.
We did till electrolytic. The next one is refining. Okay. Okay.
Yes.
So let's talk about this one. Then we start the carbon compound chapter after this one. Okay. Metallurgy. We did till electrolytic refining, electrolytic reductions. Okay. So highly reactive metals are reduced by electrolytic
Fine.
Reduction.
refining. Okay. Sorry, electrolytic reduction. Okay. Okay. Like for example, if you are having an NaCl, okay, then we use molten NaCl and we heat it. And when we heat it, okay, that I'm going to revise it one more time. So if we have molten NaCl, we have negatively charged to this one, and this is positively charged. We have NaCl inside it and molten NaCl. So Na positive and Cl minus will be there because it is molten.
Yes, sir.
So what
Yes,
would
sir.
happen when electric current is passed? Then what would happen? This is negatively charged and this is positively charged. The chlorine will goes on the positively charged particle, and sodium will goes on the negatively charged because it is positively charged, so it will goes on the cathode. So cation goes on the cathode and anion goes on the anode. So what would happen at anode, at cathode? Sorry, at anode, at positively charged. So at anode, what would happen? The 2 Cl minus ion will go. They will donate their electrons and will form chlorine atoms, and they will lose 2 electrons here. Okay. Okay. How? This is chlorine.
Yes, sir.
Cl minus S means it has normal Cl atom has 2s287 electronic configuration, means it has 7 electrons. But when Cl get 1 extra electron, then it forms Cl minus, means it is going to have 8 electrons in its outermost shell. Okay, so if we are having 2 Cl ions, 2 Cl minus ions, then what would happen? Tell me. then one of the electrons, and they have to lose one electron so that it can make bond.
Yes,
Yes,
sir.
sir.
So they will lose one electron, and they will become Cl atoms. Now these Cl atom don't have any charge because they have losing electron. Now they will combine together and will form a covalent bond like this, and this will be Cl2 gas will form. What would happen at cathode? At cathode, these two Na positive ions will go and they will receive these two electrons and will get Na solid. So we'll start getting Na positive at negatively charged rod, that is at cathode, and chlorine gas will be collected on anode. Okay, so this is how we are just collecting the chlorine gas as well as the sodium ion. Okay, so this is how we got it. Electrolytic. Now next one is electrolytic refining. Electrolytic. Have you done the homework that we have given you in the previous class? Have you done this homework? Tell me honestly.
Not all. I did few.
Sir,
You
I
did
did all.
3. You did all of them. Okay, so this is very important. First of all, turn on your camera. Everybody, please turn on your camera. I'm just turning on the focus mode. Okay, so that I can only see you. This is already on. So please turn on your camera. This is much comfortable for me that if I teach you like having your camera on. Hiba, Karishma, Abdullah and Adil, please turn on your camera. So next one is electrolytic refining. This is the very important. This is the very important part that you need to understand. This the most of the question is being asked from this portion. Okay, most of the question is being asked from this portion only. This is the electrolytic refining, and this is the most important thing. Okay, so if we are having this electrolytic refining, what happened in the electrolytic refining? Let me explain you that it is done not only for obtaining the pure metal, but it is also used to collect. It is also used to collect some precious metal. Precious metal. For example, if we are having copper, okay, copper rod or copper substance, it might not have any gangue or impurity like sand particle because we have concentrated that. We have removed the soil particles, dust particle, but it must have the atoms of the precious metals. Like for example, it is having copper atoms, then it can have gold atom, it can have platinum atom, it can have copper, then platinum. So it might have some copper atom along with it can have the other precious metals also. Okay, so it is used to refine. This method is used to refine the precious metals and to collect the precious metal also, and it is used to obtain a metal of highest purity, approximately 99.99%. Because in this process, one atom is leaving. Okay, so this is important, everybody, that you must know. Adil and Abdullah and Iba, please turn on your camera.
Yes, sir. For me, the net.
So what we does here is we take an impure metal rod as anode, means the rod which we are going to refine, we made it at anode. Okay, so that's why we are just, since it is impure, so I will making it like curve. Okay, not making it straight like this way. And we have a very thin copper metal rod. For example, if I'm just refining the copper, okay, so we'll have a thin copper metal rod. Got it? Thin copper metal rod. This is impure copper metal rod that we are just going to refine, and this is the pure copper metal rod. Okay, and then we will connect it to the electric current. Okay, the negatively charged we connect anode. Anode is okay. Always you have to note it down that
First
when,
negative, then positive.
okay, that when while we are making this one, it is arbitrarily chosen according to the guideline of IUPAC that we always in an electrolytic cell we always kept the anode at the right side and
Right side.
the cathode at the negatively charged rod at the left hand side. Okay,
Left side.
got it. So if it is negative
Yes,
and this
sir.
is positive, okay. Now, just assume that this is a pure one, okay, and this is going to have copper atoms, copper atoms, copper atoms, okay, and then gold atom, then platinum atom, then copper atom, and then copper atom, okay. Got it? Got it?
Yes, sir.
Yes, sir.
Hiba, are you there?
Yes, sir.
Why are you not turning your camera? And Abdullah, is there any problem?
Yes.
Sir, I'm not well, so
And Adil, you?
Sir, the Wi-Fi like lags the whole meeting for me.
Means you are hiding yourself. Just I cannot understand you. Means it is very much important for you that you must turn on your camera so that the teacher can check whether you are attending the class properly, you are concentrating on what I'm saying, are you looking somewhere. Okay, this is very important. Just skips the class, we are just studying online, but this is very much important. We may just feel that I'm just physically teaching you, that you are in front of me. Okay, so this
Yes,
is
sir.
must. For the next time you must arrange the camera or something, whatever you are having, but for the next time you are going to turn on a camera. Okay, everybody.
Okay, sir.
So let me explain you. So this is having, okay. Now if I told you that you have the when okay, and here in this one we are just going to have a solution of the same salt. Okay, so if I are just purifying the copper, then we will have copper sulfate as an electrolyte in it. Okay, we will have copper sulfate, Cu2 positive. Okay, I'm just making this one. So it will going to have Cu2 positive and SO4 minus 2 ion. Copper sulfate ion will be there. Got it? Everywhere will be Cu2 positive and SO4 minus 2 ion will be there. Okay. Okay, got it? So we are just going to have this one. Karishma, are you getting this one?
Yes, sir.
Okay. Now, what would happen when the electric current is passed? In this electrolyte, what would happen when the electric current is passed through it? So actually, you know that when the electric current is passed, the Cu2 positive ion will start moving towards the negatively charged rod. Cu2 positive ion will get 2 electrons from the anode. At anode, what would happen? The Cu2 positive ions will get 2 electrons and will get 2 electrons and will become copper solid. Okay, so what would happen? Let me explain you. One of the copper atom from here, from in this one, the copper ion is actually blue in color. This is blue in color. When it get electrons, then it converted into Cu2 positive is blue in color. It is blue in color. Okay, and when it get electrons, then it can convert into Cu solid. Okay, and then it becomes brown in color. It becomes brown in color. Okay, so Cu solid is brown in color. Got it? So this Cu2 positive ion will get the electrons. Got it? This Cu2 positive will get the electrons and will convert it into Cu ions. At anode, it is going to happen that anode is electron donating in nature. It donates the electrons. Okay, sorry, at cathode. Sorry, at cathode. Cathode is electron donating in nature. So at cathode, it is going to happen. Okay, not at anode. Sorry for this one. This you have tried at cathode. Okay, at cathode, it is going to happen that the two Cu2 positive ions is actually will get the 2 electrons and will form Cu solid. So one by one, these copper Cu2 positive ion from here will start converting into what? Copper solid. Okay, and it will get deposited here. It will keep on depositing over the cathode. Okay, got it? Are you getting my point?
yes, sir.
So one by one, every Cu2 positive atom will come and will get 2 electrons and will get deposited here. Okay. Then what would happen?
Sir,
Yes.
sir, could you please explain it again this point?
Yes. I'm going to explain you that we are going to have copper sulfate solution in a beaker. We are going to have a copper sulfate solution. Copper sulfate is Cu2 positive. Okay. Cu2 positive and SO4 minus 2 ion. Cu2 positive. Okay. And SO4. We added Cu2 positive and SO4 minus ion to it. Okay. Okay, now we are having a pure copper rod here. Okay, pure copper rod. and we are going to have anode here. Okay, this is impure. So this is negatively charged and this one is positively charged. When we pass the electricity, so this U2 positive atoms from here, ion from here, will move towards the negatively charged rod, and at cathode, what is going to happen is Cu2 positive ions will get the electrons, 2 electrons, okay, and will get converted into Cu solid. So one by one, this Cu2 atoms will start coming from this copper sulfate solution and will get depositing here, okay, at the cathode. Got it?
Yes, sir.
Let's suppose if this atom will get deposited here, then the concentration of SO4 ion will increase in the solution. Means there will be more Cu SO4 minus 2 ions in the solution.
Yes, sir.
Okay. SO4 minus 2 ion. If there is more and more SO4 ion, then the solution will become electrically negatively charged. Means the solution will become negatively charged. Because of this, SO4 minus 2 ions is increasing because U2 positive ion is moving at the cathode and they are converting into copper solid. So since U2 positive is removing, then SO4 minus 2 ions will increases and this will make it electrically neutral. And a electrolyte cannot be electrically neutral. Okay. So what would happen in order to balance it? The Cu atoms in the anode, Cu atoms, there is also gold, there is also platinum. Okay. So copper is more reactive. Copper is more reactive than gold, platinum. So you know that if I'm saying that sodium is more reactive than potassium, potassium is more reactive than sodium. If I'm saying that sodium is more reactive than aluminum, what does it mean? That in terms of losing the electron, sodium can lose more easily electron than aluminum. So how we make the chart of this one? How will we make the chart of this one? How we make the chart? We make the chart that those elements or those atoms that can easily lose electron at the faster rate, they are more reactive. Okay. So here, if I ask you that the gold atoms are also here and platinum atoms are also here. So if I ask you which will lose electron first, copper or platinum? So copper loses first. Okay. So unless and until there are copper atoms in this rod, they will keep on losing the electron and will become Cu2 positive ion. Okay. So from this copper atom, so what is going to happen at anode? At anode, in order to maintain the electrical neutrality of SO4 minus ion, so that it will become, solution will not become negatively charged. So what would happen? This Cu atoms in the rod, Cu atoms in the rod will lose its electron and will get converted into Cu2 positive ion. So equal amount of Cu atoms will get converted into Cu2 positive. Okay. Cu2 positive from this rod, they will become Cu2 positive, and the 2 electrons that was loose will goes into this here. Okay. So this is electrical neutrality will maintain. So this is how the Cu2 positive, the Cu solid from the anode, copper atom from the anode, which is in the rod, will get converted into copper ion. Now this copper ion will again move here. So similarly, this process remain continued. One by one, each and every atoms will converted into Cu2 positive, and from Cu2 positive, it will get deposited here. And this similarly, after some time, you will notice that this rod will become more and more thick, and this rod will disintegrate. Are you getting my point?
Yes, sir.
So what would happen? Let me explain you one more time so that you can understand. That at cathode, the Cu2 positive ion from the copper sulfate solution, the Cu2 positive ion from the copper sulfate solution at cathode, they will move and will get converted into Cu solid by getting 2 electrons. Cathode is electron donated, it will donate the electron to the Cu2 positive ion and will get converted into Cu solid and it will deposit here. And in order to maintain, because there will be, if all the Cu2 positive ion will keep on going on this one, keep on depositing over this one, then SO4 will be more and more in the, and this will make the solution negatively charged, and this is not so. So in order to maintain the negative and positive charges same in the electrolyte, the same amount of Cu atoms. So at anode, the Cu2 positive Cu atoms at anode, the Cu atoms, this is present in the rod. Okay, so Cu atoms solid will lose its electron and will get converted into U2 positive, will lose 2 electrons. So same amount of copper atom from this rod will get converted into and will comes into the copper ion. So from copper ion, it will move to the cathode, then more and more will come. So and finally, this rod will become thin and thin, and this will become thick. Okay, got it? Understood?
Yes, sir.
Yes,
So
sir.
it will be completely pure, right?
Now it will be completely pure because this AU atoms will get deposited at the end, at the bottoms, and AU platinum, the precious metal, will get deposited, and this will be considered to be as anode mud. We call it anode mud. Got it?
Yes, sir.
So let you note it down, this one. Write a note on electrolytic refining of copper. First of all, what you need to write here? What type of question will be asked? Let me explain you one more time.